Huh?
Tell us, I'm confused.
You're confused. All right, I will tell you. Don't worry. Checking for this 3.003001. The thing is, the actual number. This one is the 10. Okay. 10 then goes with
100.
here we go.
1,000.
Yeah, we go like that. So, like what happens is like here 10, okay? It's like we go with 0 times 1/10. All right, for here. For here, then we'll be going like 0 times 1/what? Yeah. Then we go like that. Okay. So for that we have this.
So what's the answer here?
You didn't tell us which one is bigger.
Oh, right. Between these ones.
There, on 10 is you are just giving us a picture on how to get smaller or bigger number. So you need to explain giving the young visitor.
What are you trying to say, Charles?
We didn't finish on why are you come up with 0 times 10 and 0 times 100. Okay.
Okay, bese ayona kusaza ukuthi yayizoshitila kune ingqondo ngeke yabo you meant ukuthi my numbers usiwo kabena you will only.
Okay, like from this point.
Just to give us a formula.
Yeah, from this point to this one. But if it is from, let's say, 1, 2 like that, then this is 10, 100. No. Yeah, 10. What?
100,000.
Yeah. So, ones.
100,000. Ones, tens, 100,000. Millions.
Like that. Yes.
Do you know?
Okay. Then number 6 was about the graph. Okay. So the first question was to find the.
Ishmael, wait, you're done with that.
Yeah.
So
Thank you.
what are you doing? I think you just wanted to explain.
Yeah. My overview is about this
Like
taking
which
for
one?
the yeah. So that was finding the equation. We all know that to find the equation, we have this. Oh, yeah. We have this mathematical formula. And for y, we all know that is this one. For x, we all know that is this one. And for m, like the slope, we all know that is 3. Alright, so we need to find the intercept.
No, can you come again?
Y-intercept. Okay, this formula, we know that this one is for y.
It's equation.
Equation. This one is for y, for output for this point. Okay? For y, this one is for x. This one is our slope. And this one the y-intercept. So, reaching this point, we have found all these, like the values of all these. So what is needed is to find the y-intercept. So we just substitute the values into this equation. What's the value of y?
And
1 m,
Okay.
then 1 plus c, like that. Yeah. It will be like 3 plus c, so c, it will just be like 3. 1 minus 3, like that. And then c will be what? Negative 4. Our equation will be like y is equal to 3x
Plus
plus c.
Minus
negative 2.
Oh, I mean negative, sorry. Negative.
2.
Negative. Like that. Okay?
yes, sir.
Yeah. So, plotting the graph. That was our last part of this question. For a graph that has like this, and the one with this cube, these are
sorry, Sharon, it's gonna end like that. We're not going to subtract.
yeah, it's just like this. This is the answer. Yeah. She was saying like to subtract this one. How come? That's
What were you thinking to subtract?
Yeah, I thought so.
Chemical.
To subtract what?
3 minus
okay, that can happen. Oh, this one, this has the this yeah, like in short,
This is the equation of a line.
yeah.
What line? You didn't make that clear. You just started saying there's a line and the point P goes in it. What line is this? Is it a random line or is it a particular line?
This one,
The question tells us what is the line that we are. This is the equation of what line? So we have to understand what we are. So
someone
I think we are going to
should help me.
no.
just
It's where we are going.
read. And let me start at the beginning. It says, for the following exercises, points P11 and Qxy are on the graph of the function f of x equals x cubed.
Yeah.
For the following exercises, the points P and Q are on the graph of the function f of x is x cubed. So there is a function x cubed. There, or you can find points on that function. Two of the points are at P, which is the point 1, 1. So 1, 1 is on the function x cubed. Yes?
Yes, sir.
And Q, x and y, will be another point on this function. Yeah?
Come on, man.
Maybe finish graphing and then
Yeah,
it'll
yeah.
become clear.
So, I was talking about the difference between these between the graphs of these two different equations. Alright? So for the better understanding, taking for this one, for better understanding, let's have like a simple table of values, like for x and y. Let's take for this, alright? Let's have negative 1. No, let's have negative 2, negative 1, 0, 1, 2. And let's take for this equation, which means we are going to be substituting this value here. So, what? Negative 8, 1 upon b, negative 1, b, 0, is 1 is 8. You see? Now, for another one, x and y, let's take for this one. For this one, negative 2, negative 1, 0, 1, 2. For this one, will be different from this one because the alright, negative 2, negative is what? Is 4. Here is 1, 0. Here is 1, here is 4. Oh, yeah. Is it like that, dude?
Yes.
Okay, so what? Everything you have is serious. Let's take 2, 4, 6, 8, 6 and negative 8. So, like for this was the first one or this one? Yes. Alright. Yeah, for this one, let's try to draw a graph. X negative 2, y negative 8, which means summary. Negative 1, summary, negative 1, that's summary. 0, 1 and 1, which means it's here and summary. Right? 2 and 8, not this summary. Like that, which means our graph will be like this. Oh, I'm not too accurate. Alright, so like for this graph, it will be different. For the x cube graph, the line always goes like down and then.
So what's the equation of that graph?
What?
What's the equation of that graph?
This graph, I was just trying to highlight how the equation for this one for x2 differs from this one.
That means if fx is equal
Yes.
to x cubed,
Yeah.
right?
So let's take for this another question. The tangent line. Linda, how do we draw a tangent line?
So I thought you said you were differentiating between,
Yeah,
Fx
but
Fx
that's a matter of time.
but no.
Just a matter of time.
No, so how can I different? Why you just
Okay, with the wow. Let me see. Should be 1, 2, 3, 4. 1, 2, 3, and 4. 1, 2, 3, 4. 2, 3, 4. Alright, so let's try to plot a graph for this. Negative 2 for x here and negative 1. Oh no,
Oh.
sorry. Negative 1 and 4.
negative two.
Negative 2 Negative 2 and 4, I mean. Negative 2 and 4 is here. So, somewhere here. What?
Instead of putting this side,
It doesn't matter.
Negative 1 here and positive 1 is somewhere here. 0, then here 1 and 1, 1 and 1 is somewhere here. And the last one is 2 and 4, which means 2 and 4. Yeah, here. So as you can see, our graph will go like this. Not too accurate, but I think you can understand. You see?
okay,
Yeah?
thank you.
So, Linda, I asked you to say, how do we draw the yeah. What? Look at this. What do you do this?
I'm not sure.
Not sure. Alright, Charles, can you help us please?
Just tell us.
Now you know how it feels when I'm standing there and you let it do.
Alright guys, the target line, the way we found it can be like taking these, let's say like this point and this point, you understand? This one, negative 2, negative 8 is square. Negative 2, negative 8 is here. And let's take from negative 1 and negative 1. Where does it fall? Here. Just checking. Could have really like a missing out. feeling like I'm missing out. Is it like that?
You're drawing a tangent?
Yeah.
That's not the tangent.
That's what it is. Then someone should help me.
Flatness.
Flatness.
Just
One important thing
maybe
when you want to
something
draw.
already going out.
Give away.
Oh, yeah. You deserve this. You deserve this. I'm done.
That's okay.
Tangent was hitting us.
I'm very about losing weight.
What?
Right? According to her explanation, she's saying that the time implying you should go like this. Oh. Touching some. Oh. Okay. Easy.
Okay.
This is the problem. Don't do I? E. Okay, but the line should touch like this part as she.
We just okay.
Can you just come in?
Okay, what?
Can you just come in?
Explain to us.
I have a question. Okay.
I'm confused also, so you ask me.
Go ask.
Regular vision hours. Very, very interesting. Thank you. I don't even know if it's important.
Oh,
I think after mid-semester we should be doing this.
doing what?
This as is. I mean,
You're enjoying it.
Oh, to have you guys teach each other.
We'll be choosing
I'm just new.
And the next one will be her.
Yeah.
This one, next one, because she's green with it.
Everybody can have a chance to explain some part. But I know we only have a few minutes.
Yeah, just
What
as it
So that
yeah, you.
Charles had a question and you had a question.
just ask me a question.
Okay, I didn't understand on how we come up with the 10
Okay, and your question?
Yeah. There we found the way on the line, why it's equal to yes. So how
Use this to draw.
to use
First, with your permission, I'm going to redraw the same graph, but on a different scale, so it's easier to see. So I'm just going to take off the labels. Actually, I won't take out the X labels. So I will redraw the points. And, so this is -8, -4, but this I'm going to make 2, 1, minus 2, or minus 1, minus 2. So they're not equal scales. That's okay. As long as we're consistent. So y is like this. Okay. So our points, we have at the origin point. Really, this one. Okay. The graph you drew was correct. I'm just drawing it differently so it's easier to see. So minus 2, minus 8. So the same way we did. We have a point here. Minus 1, minus 1. Label. You know what it is. Minus 1, 0. Actually, I'm going to add something just because it will make it even easier to see. So minus 3, minus 27. That's 1, and 3 is 27. So actually, I will change these. This. Let me just start fresh. Sorry. This is minus 30. This is 30. 3. That's minus 3. Okay, so 0, 1, 2, 3. Minus 1, minus 2, minus 3. 0, 10, 20, 30. Minus 10, minus 20, minus 30. Okay. So 0, 0, we have a point here. Minus 1, minus 1. So this is minus 1. And here, 1 is very, so we have a point there. At minus 2, we have 8, which is up there. And at minus 3, we have 27, which is about here. And then the same, it's symmetric, just the signs change. So 1, 1, 2, 8, 3, 27. Now if I join the points, it looks like that. So this is our graph of the function x cubed. Okay? Now, we know the point 1, 1 is on the graph, which we can verify. 1, 1 is on the graph, so that's this point here. Okay. And we're looking for the tangent. So when you're asked for a tangent, I can't just say, what is the tangent? You cannot answer it. You have to say the tangent where? Because the tangent here, 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 they're all different. So you have to know the tangent where. So in the question it says the tangent at P. And it will usually say that the tangent at P, or at the point 1, 1. But it has to tell you where. Or at x equals 1. But if you know x, you can find y, so you know where on the curve you are. If I tell you 1, x equals 1, then you know, this is the point 1, 1. So the tangent here. Now, the difference between a secant line and a tangent line is a secant line, this is SEC, secant, and tangent. What's the difference?
A secant line you need 2 points, while a tangent line has 3 points.
Exactly. A secant, you need 2 points to draw the line. A tangent, you only need 1 point. So the tangent here is the line that just touches at the point here. If you were to zoom in, you go closer and closer and closer and closer, you would still see the line only touches the function at 1 point. If you go in very, very close, you would see it doesn't touch anywhere else. As soon as it goes through 1, 1, after that, it's not touching anymore. The function is going like this, and the line is going like this. And the same here. So it's like taking a flat thing and putting it on a curve. On my head. It only touches at 1 point. Yeah. That's the tangent. So we want, what we're looking for is the slope of the tangent. That's what we're looking for. But,
So why the tangent is going like this direction, not
Not more. Because this is, if I move it at all, it has to go through the tangent has to touch the function, means it has to go through this point.
one.
It has to go through one. And it cannot touch anything near. If I rotate it a little bit, in it either up or down, it will touch the function somewhere else. There is only one tangent line at this point, and this is that line. But now a secant line would be, for example, if I go from here, this point, to this point, and then draw a straight line. This would be a secant. Now, can I calculate the slope of a secant? Yes. I have 2 points. I can do delta y from here to here, divided by delta x from here to here, right? And I can find the slope of that secant. Now, the slope of this line and the slope of the tangent, they are not the same. Okay. So, why do I do it? Well, let's see. Now, let me take, this is a point far away from this point. Let me take a point closer. Let's take this point and draw a secant. Straight. Okay, it's still not the same as a tangent, but it's closer. Right? Is it closer? This is getting closer to that. Let's take a point even closer. Now we start using, we didn't draw the whole table, but in the exercise, right? It's at 1, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 1. So each time we say, okay, this is the point 2, x equals 2. Let's go to, on the function, so on this curve, let's find 1.1, and we find the point on the curve. I know now it's hard to see. Now we get a secant maybe like this. Now it's getting closer to the tangent. Still not equal to the tangent, but getting closer. And then I say, okay, this was 1.1. Now let's find x equals 1.01 here. We calculate x cubed. So I have 2 points. I have 1, 1, and I have a point 1.01, comma, whatever that is. You guys can calculate it. Yeah. And then I take I can draw a secant from the point P to the other point here. I draw a secant and I calculate the slope. Right? And then I say, okay, that's closer to the tangent. Now I go even closer, 1.001. So each time I'm getting 10 times closer, 10 times closer, 10 times closer, 10 times closer. But getting 10 times closer, I will never reach 1. I will keep getting closer and closer, but I will never reach 1. And I will get lines, secant lines, that are getting closer and closer and closer to the tangent, but they will never go past the tangent. So then I say, okay, I don't have a way of measuring or calculating the slope of the tangent, because I only know 1 point. For the tangent, I only know the point 1, 1. I don't know any other points on that line. Right? I know it's the point 1, 1, and I know it doesn't touch the function anywhere else. If it doesn't touch the function, then how do I calculate any other points? So I can't calculate the slope of the tangents, but I can see that the secants can become very close to the tangent. And I can look at the pattern of the slopes and say, you know, if I kept going, and I got closer and closer and closer and closer and closer, the slopes are approaching a certain number. They're getting closer to a certain number. And we will say, even though the secants will never reach that number, it doesn't matter, right? It will be 3.0000000 all the way to the wall, 3, for example, right? There will always be a 3 somewhere. So it will never become 3.09. It will always have a little, but it will get closer and closer to 3. So then we say, the slope of the tangent must be 3. Exactly 3. The slopes of the secants are getting closer to 3, never exactly equal to 3, but the slope of the tangent is exactly 3, because that is the number that they are approaching. So then when we ask what is the equation of the tangent, as Ishmael said, well, we know now the slope is 3, because we did this exercise. And if we know the slope is 3, and we know that we only know one point for the tangent line, but one point is enough now. I know that the point 1, 1 is on the tangent line, right? I don't know any other points, but I know one point, this one. So I want the equation of the tangent line. I know that 1, 1 satisfies the equation of the tangent line. It has to, if the point is on the line, then the coordinates of the point satisfy this equation. We can check. If I put 1 and 1, is this true? Can we calculate? If we substitute the point 1, 1
Yes.
in the equation of the line, is it true?
Yes.
Yeah, 3 times 1, 3, minus 2 is 1, equals 1. Good. So 1, 1 is on this line. So this is the equation of the tangent line. So this is x cubed, the whole function. The tangent line is y equals 3x minus 2. So then we ask, how did Loveness know how to draw the tangent line? So then we have to say, okay, we say this is the y-intercept. So that means there is a point x0, y minus 2. That's the minus 2. So that's a point on the line. If x is 0, then y equals minus 2. So x 0, y is minus 2. I know the point 1, 1. Now I have 2 points. Now I can draw a line. And that line will touch the function in only one point. Did that answer the questions? Are there other questions? I know we're over time, so you might just want to move.
For the mid semester.
So we haven't done as much about limits and limit laws. One thing I want to point out, limits will not always be a whole number. In this case, the limit is 3, but the limit could be 2.5. Let me give you an example. I don't want you to be thinking limits are always whole numbers.
Yes.
Because they're not. Limits can be any number. If I say 1.99, 1.49, 1.59. Okay, what am I doing? How do I get this? Yes. Okay. 1.59, 1.50. It doesn't have to be. What number do you like? What's your favorite number? Anyway. 2. 52, 502, 5002, 50002, 50002, 50002, and so on. What number is this approaching?
Approaching 1.
What number is this approaching?
1.
No, 1.5. This is not changing, but I'm getting smaller. It's 1.5 plus something that is getting smaller and smaller. Here, this is 2 hundredths. This is 2 hundredths. Here, this is 2 thousandths. Here, this is 2 ten thousandths. Here, this is 2 hundred thousandths, and so on. So it's 1.5 plus something that is getting smaller and smaller. eventually it gets almost 0. So 1.5 is the number that this sequence is approaching. And we say the limit is 1.5. I could make this anything else. Pick two numbers you like. Any two numbers.
7 and 4.
7 and 4. Now what is the limit of this sequence?
1.74.
So there's a part that you can see it's getting closer and closer to this. Of course, if the limit goes up, it will look, that's a good idea. Let's do it. This is a sequence that's going down towards the number, right? But you can have a sequence that goes up. Let's not make it 1, let's make it 8.3. 8.33, 8.333, 8.3333, 8.33333. What number is this approach?
8.3.
18.
No, not 8, not 8.3. It started at 8.3, but now we keep adding a bit more. And we're always adding more, a little more, a little more, a little more, a little more. But not 8.4.
8.5.
This will never get close to 8.4. This will become 8.3 repeating. Do you know this notation? You've never seen this? Like this or like this, 8.3 dot? Or dot below. I never use the dot, so I don't know the dot notation. I always do that. This notation means that this number will repeat forever. Yeah? So the limit, here, the number always stops. So just keep adding another 3, another 3, another 3. So they get longer, but they always have the limit. The limit is this, which is equal to 8 and a third. If you try to write a third in decimals, it's 3.3 repeating forever. So we call this repeating. And you can have, you can have 0.12 repeating, which is 0.12, 2, 2, 2, forever. So you can have any number of digits that will repeat forever. And they can be limits. Any real number can be a limit. Pi can be the limit. A limit can be any number. Even a very long decimal number. That can be the limit. The point is, do you have a sequence of numbers that are getting closer and closer to what? So one way is you can look at the pattern of numbers. The other way is to look at the graph. And you see, if I ask what is the limit here, you say, well, here the value is this. It's getting closer and closer to this number, whatever that number is. It's like 17. Okay. But notice, if I have a function and I put a hole in the function, remember this is a hole? Remember? This is a hole, which means if this is x equals 6, then f of 6 does not exist. Right? At 6, there is no value of f. The function does not exist at 6. But everywhere, tiny, close to 6, it exists. What is the limit? And then I say here, y-axis, let's call this 2. What is the limit of f of x as x approaches 6? So, as you take values of x closer and closer to 6. You don't care what happens at 6, but as you get closer to 6, like we did before, here, 1.1, 1.0, 1.00. So here we take 6.5, 6.1, 6.05, 6.301. You get closer and closer. The function values are also getting closer to something. The number that they are getting closer is this, right? You say, well, this point, and then this point, and then this point, and then this point, and then this point. Well, they're all getting closer to this. Okay. So the limit is 2. F of 6 does not exist, but the limit of f of x as x approaches 6, that is equal to 2. So you can have a limit without having the function value. Or you could even have the function value as something else. You could say f of 6 equals 3, but the limit is still 2.
Yeah. 8 and a quarter, does it exist?
8 and a third?
Yes.
Do you think, is that a number?
It's not a number.
Huh?
It's not a whole number.
Not a whole number, no, of course not. It's a decimal.
So, if,
It's a rational number,
yeah,
which is also a real number.
so you say it is existence.
That's a good question. Look, in mathematics, the question, does it exist, is a very good first question. Because you can do all kinds of work, and at the end you find out, it didn't even exist. Why did I do all the work? That's a good question. Does the number exist? Yes, this number. This is a real number. It's a rational number. You know why they're called rational numbers? Rational, you know rational numbers?
Yes.
Do you know why they're called rational numbers? Is it because they make sense, rational? No. It comes from the word ratio. Ratio is a division, like a quotient, right? A ratio. 3 to 4, 7 to 2. That's a ratio. Rational numbers can always be written as a ratio. So 8 and a third is 8 times 3 is 24, plus 1. 25 divided by 3. This is a ratio. 25 to 3. Every rational number can be written like this. An irrational number, like pi, cannot be written like this.
So, sir, which means for the mid semester, we just need to focus on
So, I may have to change the exam a little bit,
yes.
because we didn't cover the limits so much.
Yes.
I might leave the question, but make it optional, like a bonus question. So you should still study the limit. Limit laws are simple. So then if I say, okay, this is equal to 2, I say, this is equal to something, a limit, we call it L. Traditionally, capital L, but it could be any letter. M, K, doesn't matter to me. Okay? Now, if I have another function, we call this one U of x. It has a limit K, let's say.
So, no, we need a lot of time of doing this course. We said it is related to the derivatives. Okay? Yeah, so if we can't understand these limits, that means derivatives will be tough to us.
If you understand this, that as we take the limit of the slopes of the secant line, we get the slope of the tangent line, that's all we really need for derivatives. Textbooks and courses usually require, which this one does, the course outline, that we cover limits and the laws of limits. But also, if we don't do too much of that, it's also fun. We can still learn derivatives. Okay, I think we should stop there. Your grades have been hot. The engine is going.
No, that's a question. Just keep going.
Okay. So,
Apart from the functions, focus on
I've said it before, I will say it again. If you have questions, yes, ask each other. That's good. If you want to ask me, ask me. I'm also here for that. In university, your lecturers are available to you if you have questions. So, the learning is your responsibility. But part of taking responsibility for your learning is to go and ask questions. Say, can you help me understand this? Can you understand that? I can't do the learning for you, but I can help you. And I'm happy to. I want you all to do this. You can all learn this. It might take some of you a bit more time to learn certain things, but you can all learn. Okay. Everybody signed the attendance sheets? I haven't completed them yet because I was away since last week. But I will try to get them to you this evening.
Where have you been? Where have you been?
Where have I been?
Yes.
I went to Salon.
Why don't you try to play the news? You know,
Pick
I
me
want
when
to see
you.
you know, start playing guys. I want to see outside this country.
I'm sure.
I'm born here and I'm staying and I'm going to die in this country. I don't have chance to go outside. So,
I hope
You have the chance.
I hope
me,
I hope everybody gets to go out and then come back. Because your
Yeah.
country needs you also.
I can't wait.
That's why you're here, to learn how to be a benefit to your country.
Okay, thank you.
Yes.
we need to
Hi.
Oh,
Oh my God.
you have multiple choice.
No, mostly it's just calculation. I mean, like the exercises.
No multiple choice. Some we can, yeah.
I don't think I can.
We can survive. We can survive there. Yeah. We can survive a little bit.
It's a challenging exam. You have to do very well.
You will die, which means you will going to die.
You might. I will bring you back to life.
You're fishing, I said.
Hi. Hi.
I hope you're fish.
Yeah. Is it stopped?